All right, everybody, we are going to be going over a few examples of how to draw compounds and what the College Board is going to be expecting from you. Now, the first compound that I showed you on the list is LiCl. Now, LiCl is an ionic compound, and you say to yourself, how in the world am I supposed to remember that? Well, if you look, lithium here is a metal, Cl is a nonmetal, and a metal and a nonmetal together give me an ionic compound. So that is how I know. Usually on an AP chemistry test, they are going to ask you a compound question about an ionic compound in one of two ways. One is that they're going to give you a picture and ask you to label the appropriate atoms. The other one is that they're going to ask you to draw a picture and label the appropriate atoms. So the big thing with these is that they want you to tell them that you understand how the size of the atoms work. If you look and we compare lithium to chlorine, okay, so Li to Cl here, think about which of them is going to be smaller. In this case, the Li is going to be smaller than the Cl minus for a couple of reasons. One, the Li is going to be Li plus in the ionic compound, so that means it's going to actually be even tinier than normal because it's a positive ion. Additionally, it is in the second period, whereas Cl is in the third period. So there is an extra layer of electron shells, and so in the case of this particular compound, Li is going to be the small one, and Cl is going to be the big one. So I can do this one of two ways. If they ask me to label it, sometimes they'll give you a legend. I would say that we have Li as the small one, and Cl minus as the big one. The other way they could ask you to do this, and I've seen them when you draw a solution, you would draw the Li as an Li plus, and then larger Cl as a Cl minus. When it's an ionic compound, you need to make sure that you represent the charge of the ions, like I forgot here because I'm a delinquent. So you need to make sure that you have those in your picture, otherwise you don't get the points, but the size is going to be the important one here. Okay, so that's what they're going to be doing for ionic compounds. Now, covalent compounds, on the other hand, require a Lewis structure. And so number 2 that I asked you to do was NF3. If you did this before, you did the practice for it, and you think you got it, I really hope you did. If not, and then you're a little rusty, that's okay. Now, what we have to remember is when we are talking with our periodic table, the oxidation number is different than the number of valence electrons. So in group 1, I have 1 valence electron. Group 2, I have 2. We skip the transition metals here because they are problem children, which you should know by now. But in group 13, we have 3 valence electrons. There are 4 valence electrons in group 14. Then it goes 5, 6, 7, and 8. And so when we talk about our valence electrons, it's only going to be a number 1 through 8. What I see a lot of people do when we're drawing Lewis structures is that they're not careful and they actually end up using the atomic number. So if I'm talking about, let's say, carbon in a Lewis structure, people say that carbon has 6 electrons, which is true. It has 6 electrons total, but when it's making bonds, it's only bringing 4 of those electrons to the table because the other 2 are 4. So just be careful with that. So my first step with these always is to figure out the number of valence electrons. When I do this Lewis structure, nitrogen brings 5 electrons to the party, and each fluorine brings 7 electrons to the party, but there are 3 of them, so I'm going to say times 3, and then I'm going to add those up, and then I'm going to get a grand total of 26 electrons. Unless something weird happens, you should end up with an even number of these all the time. Okay, so I'm going to kind of back off a little bit here, hopefully you can see. All right, so since nitrogen is written first, I'm going to put nitrogen in the middle of my Lewis structure, and then I'm going to draw that skeleton around it. I tend to draw my elements just kind of evenly distributed around my central atom to see how things go. So I've got 26 electrons. To make all of these connections, I had to draw 3 lines, and each line in this Lewis structure represents 2 electrons that are shared between those elements. So nitrogen is sharing electrons with fluorine, and I have 6 represented in my picture. So what I do is I take 3 lines times 2 electrons represented by each line. So I'm going to subtract 6 electrons here, which leaves me with 20 electrons to put in my picture. What I do then is I start outside and add electrons. I'm going to go 1, 2, 3, 4, 5, 6. And the reason why I'm going to put 6 electrons around fluorine is because each element in my electron configuration, my Lewis structure, needs to have 8 around it in the picture to have what we consider a satisfied octet. So when I cover up everything except fluorine, I have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now, these electrons that are shared count for fluorine's count and nitrogen's count. That's the whole purpose. It's a bond, so we each get to count those electrons. But right now, we're just sharing these, so fluorine has 8. So I'm going to keep going, recognizing that I only have electrons to put in my picture after I've drawn in my bond. So I've got 2, 4, 6, okay, 7, 8, 9, 10, 11, 12. This fluorine is good now, and I have 12 dots drawn into my picture. 13, 14, 15, 16, 17, 18. So this fluorine here has a satisfied octet, and I have 2 dots left from my 20 electron dots that I have to put in my picture. If we look here, nitrogen only has 6 electrons drawn around it, so I need to add 2 more to satisfy my octet rule. Now, if I check, fluorine has 8. The second fluorine has 8. The third fluorine has 8. And nitrogen has 8. And so in my Lewis structure, everything is good to go. Now, if you feel like drawing the dots in is super cumbersome, which in this one it's not so bad, but eventually it might get to be kind of annoying, there is kind of a shortcut that you can do once you get confident with these, and it's to draw in a line instead of a pair of electrons. So these dots, if you like the dots, keep them in. But if you don't, draw the lines. So this is also an acceptable Lewis structure for nitrogen, okay? Sometimes on the test you will see the actual dots drawn in, and so you'll see the dots drawn in as a shared pair, but it's the same thing. So that is kind of our basic structure. Number 3 is the nitrate polyatomic ion. If you remember, our polyatomic ions are actually covalently bonded clusters of atoms that have a permanent charge on them. So we'll do the same thing for NO3 and see how you do with that. NO3, its valence electron count, 5 electrons come from the nitrogen to the party. Each oxygen brings 6 electrons. I see a lot of people say oxygen brings 8, but oxygen only brings 6 valence electrons to the party. And then there are 3 of them, so that's times 3. And then this -1 charge here means that there is an additional electron that added into our compound. So I'm going to add another electron to my total. So if I look here, I've got 18 plus 5 plus 1 gives me a grand total of 24 electrons that I'm allowed in my picture. Again, I can't add more electrons, and I can't put in any less than those number of electrons either. Okay, so my likely center is going to be the nitrogen, and I'm going to put 3 singly bonded oxygens around the center to start off with. Each of these lines represents 2 electrons that I have in my picture. So I'm going to take away 6 electrons. And so I have 18 electrons that I'm allowed to put in my picture, which translates to 18 dots that I can put in. And I have to put in that many, okay? So I'm going to start over. 1, 2, 3, 4, 5, 6 dots in. This makes oxygen have a satisfied octet, okay? 1, 2, 3, 4, 5, 6. That's 6 electrons to the second oxygen, and 1, 2, 3, 4, 5, 6 here. So if I look at this, I say to myself, I've got 18 dots in here, so I should be good to go, right? Stop your Lewis structure, stop the rest, everything's done. However, if you check out your octet rule, the oxygens all are good, but the nitrogen is short 2 electrons. So in this Lewis structure here, the nitrogen only has 6 electrons, not 8, and that is not okay. It's not allowed. If this were boron, it would be fine, but it's not, so we've got to deal with it. What I do in these situations where I am short is I take electrons from any element that is satisfied in it, and I share them between the satisfied element and the middle one. So in this case, I'm going to steal 2 electrons from oxygen and slide them down into the area between nitrogen. Now, I don't have a pencil, so I'm going to have to redraw this, but if you have a pencil, you just erase and kind of restart. So I'm going to have nitrogen in the middle, but now instead of 1 bond, I'm going to have 2. If you find yourself short, like let's say I only had, I was short and I was missing this guy too, what I could do is I could move another pair down and have a triple bond, and that's what you see in a triple bond. So I'm going to redo these numbers just to make sure. I have 24 electrons, and I put now 1, 2, 3, 4 bonds. So I'm going to take away 8 electrons from my picture, so that leaves me with 16 electrons to put in. Now this is a little different here because this oxygen only needs 2 electrons, pairs there. The O at the bottom gets 6, so I've got 2, 4, 6, 8, 10, and then 12, 14, 16, and I only had 16 electrons to put in my picture here. I'm going to draw that a little better. And so that is the correct Lewis structure. The other thing you need to know is that if I have an ion, I need to put brackets around it and then the charge. So I'm going to put a -1 around that as well. Okay, so if you find yourself short of electrons, you've got to draw multiple bonds in there, whether it's a double bond or a triple bond or 2 double bonds, depending on your Lewis structure, and that will help you solve your octet problems. Okay, we are going to be moving on to 3 more examples in the next video. These get a little harder, so don't be surprised if you struggle with them a little bit, but hopefully we'll get things cleared up and you'll be off to the races.